Good afternoon, everyone. Today we will study section 4.9 antiderivatives and the start of chapter 5. Chapter 5 about integration, Riemann sum and integration. Good. Let's start here. Do you remember these two theorems from section 4.2? Theorem 5, if f prime of x equals 0 for all x in an interval, open interval AB, then f is constant on the open interval. Good? See this corollary now. If f prime of x equals g prime of x for all x in an interval open, then f minus g is constant on the open interval AB. That is, f of x equals g of x plus c, where c is a constant. I wanted to remind you about these two theorems. Why? What do you think? Because, you know, when you integrate, you add constant, right? These two theorems, they are the reason why we add constant, okay? Let's see the definition of antiderivative. So, I will also give example. So, let's take a screenshot of that. Good. So a function capital F is called an antiderivative of small f on an interval I if capital F prime of x equals small f of x for all x in I. Good. For example, if I give you small f of x equals 3x squared. So small f of x equals 3x squared. I want the antiderivative. So I want a function capital F of x that when I differentiate it, I get 3x squared. What's this function? What do you think? You need to participate, okay? Do you hear me?
Yes.
Yes. Yes, tell me.
We can raise the power by 1 and then divide by the new power, so it would be just x power 3.
Yes. So x cubed. Do you have another example other than x cubed?
Professor, can you explain again, please?
Yes. So a function capital F is called an antiderivative of small f on an interval I if capital F prime of x is equals small f of x for all x in I. So remember, chapter 3 and end of chapter 2, we were differentiating functions, right? For example, x cubed goes to 3x squared. For example, e to x goes to e to x. But what about getting back? For example, if you have 3x squared, how can you get back? By integration. It's called antiderivative. Okay? The derivative is 3x squared. What's the antiderivative? It's x cubed. You get back. Okay? Is it good?
Antiderivative is integral, basically?
Yes.
Okay.
Now, but with integration you can get back to more than one function, right? For example, I can take x cubed plus 1, right? What's the derivative of x cubed plus 1? X cubed. I mean 3x squared. For example, x cubed plus 10, for example. What's the derivative? 3x squared. Plus 100, for example. Plus 1001. Plus this number. Or this number. Or this number. Like this, right? You have infinitely many antiderivatives for each function. How to write it in general? We add
Plus
constant.
c?
Yes. So plus c, constant c. And the reason is the theorem from section 4.2, mean value theorem, that if you have, for example, f1 prime of x equals f2 prime of x on open interval, then the result is f1 of x equals f2 of x plus c. This is by section 4.2. Now let's go to see here this graph. This graph is very much nice. This is a graph for the family of curves that their family of antiderivatives of f of x equals x squared. See here, what's the effect? They are vertical. I mean, they are vertical shift of each other, right? So if you shift them vertically, you get another solution. Now, yes, let's solve these. These are important. So, Bishar,
Hi, Professor.
yeah, please help me with solving this. Find the most general antiderivative of each of the following functions. Help me with part A. What do you think? The antiderivative of sine x. What's the function that when you differentiate it, you get sine?
Cosine.
Are you sure? Look, cosine, if you write just cosine, what's the derivative of cosine? Derivative of cosine is minus sine x, right? So you need what? You need to multiply by minus 1. Good?
Oh, yes, sorry.
So minus cosine x. Thank you. Now, Ayan. Ayan,
Yes, Professor.
please help me with part B. You want the most general antiderivative of 1 over x.
Will it be ln of x?
Yes. So len absolute value of x plus c.
Yeah.
I will tell you why I put absolute value. Look here. The answer len x for x greater than 0, right? Plus c. But forget about the constant now. I mean, let's see just the len x. So len x for x greater than 0. Because this is the domain. What's the derivative of this? 1 over x. Good. Now look at len minus x, x less than 0. What's the derivative of this? We use chain rule, right? It will be 1 over minus x times derivative of inner, which is minus 1. What do you get? 1 over x, right? So you have two solutions for it. How to combine them in one solution? You put absolute value. Good? Is it clear?
Yes, Professor.
Yes, Professor.
Now let's solve the last one. F of x equals x to n. For n is not minus 1. Minus 1 is solved in part B. So forget about minus 1. What about other values of n? What's the most general antiderivative of this? F of x equals what? Let's see
X to the power n plus 1 divided by n.
So x to n plus 1, and we divide by n plus 1, okay? Good. See here that minus 1 doesn't even satisfy. I mean, it's not in the. You cannot substitute it because you will get 0 down. So plus c. Now let's get back to part B. You remember that yes, let's continue. So you remember that we add constant because of the theorem from 4.2, right? Let me show it to you again. See this one. F prime of x equals 0 for all x in an interval AB. Same with the next one. The next one is the important one. if f prime of x equals g prime of x for all x in an interval ab, then f equals g plus c, right? But now, len absolute value of x, I will show you. Len absolute value of x equals what? Equals len minus x if x negative. Len x if x is positive. So we don't have one open interval, right? We have here one open interval and here one open interval. So we have two open intervals, right? Good. What's the meaning of that? That the solution will be here plus c1, okay, and here plus c2. This is the antiderivative of 1 over x. So for 1 over x, when you find the antiderivative, you get this. The two constants are not necessarily equal. Good? Because for each open interval, you have its constant. Good? But you have two open intervals, so you have two constants. Are you good with this? It's here. I will show you. So here, you have two open intervals, minus infinity to 0 and 0 to infinity. So the general antiderivative of f is this one. If x is greater than 0, len x plus c1. If x less than 0, len minus x plus c2. Good? Do you have questions?
No.
But here, this is just for understanding. We will consider the answer what? Len absolute value of x plus c. We will consider it just one constant, okay? So here you have len absolute value of x plus c, right? So just write plus c. Forget about this here. Here this is just for understanding that this in fact is the most general antiderivative for 1 over x. But we will consider it len absolute value of x plus c. This idea here is important. In general, it's important to know that when you have two open intervals, then you have two constants that they are not necessarily the same constant.
Assalamu alaikum, Professor. Sorry, you put the link of the meeting in, like, I think titled link of the video, so I was trying to find the link and I couldn't find it.
Yeah, I put it in the body of the video. I mean the announcement. Anyway, let's continue. Now, see this table of anti-differentiation formulas. When you multiply a function by constant, the particular antiderivative, just multiply c times the antiderivative of f. So c, no problem with c when you multiply by constant. And addition, you add the two antiderivatives. X to n, it's x to n plus 1 over n plus 1 if n is not minus 1. 1 over x, then absolute value of x. E to x, e to x. B to x over len b. What was the derivative of b to x? What do you think? Do you hear me?
Can you repeat?
Derivative of b to x. What's the derivative of b to x? Asian, do you hear me?
Yes, Professor.
Do you know the derivative of b to x?
Could you repeat that again, please?
What?
Could you repeat that again?
Derivative of b to x. Constant
Derivative of E.
b power x. So
So
constant
it
power
would
x.
be P power x by ln of b. Ln of b.
For derivative, you multiply by ln b, right?
Yes.
But for antiderivative, see the difference? When you find the antiderivative of b to x, you get b to x divided by ln b. So this is the difference between antiderivative and derivative. For antiderivative, you divide by ln b. For derivative, you multiply. Good?
Yes.
Now cosine x. The antiderivative of cosine x is sine. Sine x, the antiderivative is minus cosine. Secant squared tan x. Secant x tan x, you get secant x. 1 over square root of 1 minus x squared, sine inverse x, or minus cosine inverse x. Because what's the derivative of just cosine inverse x. What's the derivative of cosine inverse x? It's minus 1 over square root of 1 minus x squared. Multiplied by minus 1, you get this one here. 1 over square root of 1 minus x squared. So you can answer this one sine inverse or cosine or minus cosine inverse. But be careful that sine inverse and cosine inverse, they have different domain. No, the domain is the same thing for cosine inverse and sine inverse, but I mean the range. See, for cosine inverse, the range is 0 pi. Range for sine inverse x minus pi over 2 to pi over 2. Now see here, 1 over 1 plus x squared, the antiderivative is tan inverse x. Here you have hyperbolic functions, hyperbolic cosine and hyperbolic sine. Hyperbolic cosine antiderivative, sinh x. Sinh x antiderivative, cosh x. These are not included with you, but if you are curious about this, here is the definition. Cosh x equals e2x plus e2 minus x over 2. Sinh x equals e2x minus e2 minus x over 2. Cosh looks like similar to quadratic. Sinh similar to x cubed. See here you have this identity. So it's similar to trig functions. So for trig you have cosine squared plus sine squared equals 1. For these hyperbolic functions you have this identity. But forget about this, it's not included with you. Now let's solve this one here. Now Aisha,
Yes, Professor.
please help me solving this.
Okay.
Here we want to find the antiderivative, okay? So we have,
Okay.
but first we need to simplify, right? Because this here is not ready yet to find the antiderivative for it, because we need to divide first. So you have
Yeah.
g prime of x equals 4 sine x. This is ready, good. But the next one,
Yeah,
plus
for sine x.
2x to 5 over x, it will be 2x to 4. Then minus x to half is a square root, okay? Over x, it will
Yeah.
be half minus 1. Half minus 1, but half minus 1 is minus half.
Minus half. Yes.
When you integrate, it's good to write it like this, x power n. So this one here, don't write it as 1 over square root of x. Write it as x to minus half, x to n, to make it
Yeah.
easy for integration. Now let's do it.
Yeah.
G of x equals what?
It's going to be minus 4 cosine x. Cosine 4x, sorry.
No, it's correct. Minus 4 cosine x.
Okay.
Plus
Plus, here it's gonna be
2 times
x to the power 6.
5. You add 1 and divide by the new exponent. So it will be multiplication by the reciprocal. So 1 over 5, okay?
Yeah.
Minus last one, you have x minus half plus 1. What's minus
Plus
half plus 1? Half, right? Positive half.
Half.
Then you multiply by the reciprocal of this, which is 2. Are you good with this?
Yeah.
Let's see. Thank you. Now Let's solve 13. Now, Redhima, Amin.
Yes.
Please help me solving this problem 13. You have f of x equals 3 square root of x minus 2 cube root of x.
Uh,
We want
3.
antiderivative, we want.
Yeah, okay. 3 into x raised to the power 3 by 2.
But first let's write it as powers before integrating. So 3x power half minus 2x 1 over 3. Now tell me your solution.
Okay. 3 into x raised to the power 3 by 2 into 2 by 3.
Yes. 4 over 3 this time.
Yeah, minus
3
yeah,
over 4.
into 3 by 4.
Thank you. Now let's see this problem here. Now, Yusuf,
Yes.
can you please help me solving this one?
Yes. So we just multiply it out. So we have 12x squared plus 8x. And then we integrate. So we get 4x cubed plus 4x squared.
Thank you. So we add 1, it becomes a 3, divide by 3, 12 over 3, 4, and same with the other one. 8 divided by 2 is 4. Now, thank you. Let's also add constancy. Next we have, yes, this one is good. Problem 14. Now we have Ghaya.
Yes, Professor.
Please help me solving this one. G of x equals the square root of x2 minus x plus 6x squared. Do you know how to solve it?
I will rewrite the square root.
Yes, perfect. So we write it x to half, then what? We multiply, right?
Yeah.
2x to half, then minus x to half times x, it becomes half plus 1. Half plus 1, 3 over 2. Plus 6x squared plus half.
5 over 2.
5 over 2. Now the antiderivative. G of x equals 2 times x2, add 1, becomes 1 plus half, 3 over 2. Then multiply by the reciprocal, 2 over 3. Then minus x, add 1 here, it becomes 5 over 2. So 2 over 5 times x to the power 5 over 2. Then plus 6 times x. Now here add 1 to the exponent, you get 5 over 2 plus 1, 7 over 2. Multiply by the reciprocal, 2 over 7. Do you have questions about this? And also plus c.
No.
Okay. Now yes, now this problem is good. Problem 15. Now Shayan,
Yes, Professor.
please help me with this one. What do you think?
First, simplify.
Yes, perfect. So f of t equals,
2 under t.
this one is t2 half, okay?
Yeah.
So first term, 2 times what? 1 minus half, which is half, right?
Yeah.
Then the next one, minus 4 times what?
Minus 1 t minus 1 over 2.
Yes,
Yes.
thank you. Then the last one,
3 t 3.
yes, thank you. Now f of t equals what? The antiderivative.
You add 1 to the
So 2 times, add 1 to the exponent, you get t power 3 over 2. Then multiply 2 over 3. Minus,
it's minus 2 t squared. No, minus.
1 minus half, right? It's positive half. You multiply by 2. Good? Last one.
3 t.
Yes. Do you still need to write something here, right?
That's c.
Yes, thank you. Yes, we have this problem is nice here. 21. Now Maria. Do you hear me?
Yes.
Please help me with this problem. F of theta equals 2 sine theta minus 3 secant theta tan theta.
We'll use the product rule.
No, here antiderivative.
Okay.
So antiderivative of sine is minus cosine. So minus 2 cosine theta. Then the other one, secant theta tan theta, will be secant theta for the antiderivative. So minus 3 secant theta. Thank you. Now the next problem. Now we have Hannah. Hannah Ahmed.
Yes.
Please help me with this problem. G of V.
Okay, so we have to put the square root as half, and then a minus half, and then 2 cosine V is 2 sine V.
2 sine V. This one is ready. No need to change it. Because this one is sine inverse. Minus sine inverse. Minus 3. Because we have 3 up. So minus 3 sine inverse of V. Another solution. Plus 3 cosine inverse V. So you have this solution or this. As you like. Thank you. Now let's go to the next section now. Now the area. You know that we have area of triangle, for example. It's half base times height. We have area of rectangle, width and length. You have area equals LW. You have area of circle. But what about if I have x squared, for example, as this example? I want to approximate this area, for example, up to 1. What do you think? What can I do? I don't have formula for this. How can I find the area? What do you think?
By integrating?
What? What's your idea?
But by integrating
Yes, you are right. By
the area
integrating.
under the curve,
But if you assume you don't know integration, what can you do?
find the antiderivative.
No. Assume you don't know this yet, and you want. It's necessary to find this area. What can you do? You can do like this, right? You can draw rectangles, right? And you know the
Yeah.
formula of area of rectangle, and you add them, right? You get approximation. You can do this if you don't know integration, right? Good. So this is the idea. Also, integration comes from this. But here, there is two ways to do. Not only two ways, many ways. But I mean, left points and right points. They are famous ways. See here. First, we divided the here between 0 and 1 sub-intervals, 8 sub-intervals. See, we have 1, 2, 3, 4, 5, 6, 7, 8, right? You have two ways. You can take the height to be left end point. Okay, see here. For this one, the height is the left end point. See here, left end point, 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 left end point. See the other one. We can start here, right end point, right end point, right end point, like this. Okay. You see here that this is overestimate, right, of the area, because it's more than the area. See here, you have error. You have positive error. It's more than what we want. Right? See the other way. Here, the left end points here gives you lower sum. You have this is not with us. We need this. We need this. We need this. Right? So these both are approximations. They are not exact results. How can we get better results? What do you think? What do you think, Ilyas? Do you hear me?
Yes, Professor.
I will ask you this. Here we are estimating the area, right, by rectangles. But it's not good enough because we have these things, right? They are not included. How can we make this approximation better? What do you think?
More rectangles?
Yes, perfect. Thank you. So when you keep adding more rectangles, you keep getting better results, right? So this is the idea. If you take the limit as n goes to infinity, if n is the number of rectangles, you get exact result. Okay? So here, let's see this one. I mean, let's write it as a formula for this one. I'm using left endpoints, right? So I start at x0 when I use left points. x0 up to x7. And the width of each rectangle is delta x, the same width for each of them, because they are equal subdivisions, okay? So you have, for the first rectangle, you have x0 times the height, right? What's the height? Height is fx0, the image of x0. Then plus x1, f of x1, the height. Then x2 plus, not plus, f x2 I mean. Then up to, until you reach x7, fx7. So this is left endpoints. See here for x7, for example. What's the height? Is the image, the f value at what? At x7, right? But now see the other way. If you use right endpoints, I will write it in red, okay? See here. You start from x1 for right endpoints. So you have fx, not x2 here. Here delta x. Delta x. These are delta x, sorry. Delta x. Delta x. Now let's do the right endpoints. So you have, let's do it again. So you have delta x fx1, right? Plus delta x f of x2 plus delta x f of x8. So when it's right endpoints, you start at x1 and you stop at xn. xn in more generally xn, but here it's 8. Here, for left endpoints, you start at x0, you stop at xn minus 1. Here it's 7 because n minus 1, I mean n is 8, minus 1 is 7, okay? Are you good with this? Do you have questions?
No, Professor.
Okay, let's continue. Now, see here. The area is A. When you use left endpoints, you get 0.27. When you use right endpoints, you get 3.39. So the area between these two numbers. Now see the definition. A equals limit Rn as n goes to infinity. This is the right endpoint sum. See here the formula. The height times the width plus the height times the width until you reach xn. You start at x1, you stop at xn. And you multiply by delta x. See down, you have ln, left endpoints. If x0, you start x0, you stop at xn minus 1. Fx0 delta x plus fx1 delta x until you reach fxn minus 1 delta x. Not necessarily left or right. You can use midpoints. Where is it, the midpoint? We could take the height of the... No, this is the most general. But I think they also talk about midpoints. Anyway, more generally, you can take sample points. See here, we divide the between A and B, we divide the real line into n sub-intervals, right? They are equal sub-intervals. For the height, when you want to find the height, you can draw the rectangle by choosing sample points. For example, x1 star here. So make this to be the height. The image of x1 star, I mean. Look at x2 star. So you can choose sample points, not necessarily left points or right points or mid points. You can take any point between the, I mean in the subdivision, okay? But the important ones are right sum and left sum, okay? If the sum is less than the area, you call it lower sum. If the sum of rectangles is more, you call it upper sum, okay? Here you have them together. You have upper and lower sums. Now let's solve this exercise. Estimate, no, not, this is already solved. I will solve the one here, okay? We will solve this one now. But let me show you something. You can open Dismos. If you want to graph and see the rectangles, you can use Dismos like this. See here. I will show you our example. It's 25 minus x squared, right? See here. 25 minus x squared. We want to integrate between what? Between minus 3 and 5. Let's do it. So a, make a minus 3. B 5. Then, how many rectangles do we want? We want using 4 subintervals. So 4 rectangles, right? So n equals 4. Next, see here. C equals 0 means left hand sum. C equals 1 right hand sum. Z equals 0.5 midpoint. Okay, see here. If I C equals 0 left hand, see this is the left hand. We are using left hand point now. See 0.5. 0.5 is midpoint. We are using midpoint now. Now C equals 1. C equals 1 is right hand. Good. This I don't know, 1.5. But the value C is equal 0, 0.51, okay? And here you have the exact result. If you want, you can add more rectangles, see? See? It's getting better. No, I mean here, see here. So even before reaching infinity, 100 rectangles may give you something very good. But when we integrate, we will get the exact result. Because integration is the limit of the Riemann sum. Limit as n goes to infinity is the integration, okay? So it will be easier to integrate. But we need to understand this. So we use this to understand. Now let's solve it now. Yes, let's start. So here you have 25 minus x squared minus 3 to 5. Now you need to use this formula, delta x equals b minus a over n. So delta x equals, what is b? b is 5. A is minus 3. So 5 minus 3 over n. What is n? N is the number of rectangles. So 4. How much this? 5 minus 3 is 8. So 8 over 4, you get 2. Good? So this is delta x. We have 4 rectangles. Part A, we are using right endpoints in part A. So for part A, since we are using right endpoints, we start at x1, right? But first, what is x0? In general, we need x0 to find x1. What is x0? x0 is minus 3, right? It's this one here. This is x0. Now let's solve use Riemann sum to estimate the area under the graph and take the simple points to be left. Yes, this is part A. We need to solve part A first. So you have x0 equals minus 3. What is x1? See the formula? xi equals a plus I delta x. So x1 equals a means x0, okay? So x0 plus I is 1 here because x1 plus delta x. What is delta x? 2. So you get minus 3 plus 2 minus 1. Next, x2 equals x0 plus 2 delta x. So you get minus 3 plus 2 times 2 minus 3 plus 4, 1. Next, x3. x3 equals, so x3 equals x0 plus 3 delta x. It will be 3. So every time you add 2. x4, you get 5. Good? For left endpoints, we need x0 to up to x3. So let's find L4. L4 equals delta x times f of x0 plus delta x f of x1 plus delta x f of x2 plus delta x f of x3. That's for left endpoints. For right endpoints, let's do now the right endpoints. The right endpoints will be, you start at x1. So f x1 delta x plus f of x2 delta x plus f of x3 delta x plus f of x4 delta x. You can take common factor if you want. So it's delta x, then you add f of xi, I equals 1 to 4, okay? This is the sigma, the big sigma symbol for summation, okay? Now for part C, midpoints. What do you think? How to find the midpoints? Do you hear me?
We can hear.
Yes. Do you know how to find midpoints?
No, I don't. Maybe take like between left and right. So, for example, if we have 2 and 3, we take 2.5.
If you have 2 and 3.
Yes, if like the right hand point would be 3, and the left hand point would be 2, where the midpoint would be 2.5.
Yes, exactly. Yes, this is the idea. For example, here, -3 to -1. How to find the midpoint? You find x1 minus x0, divide by 2. Okay. x1 is -1. -1 minus -3 over 2. It's 2 over 2, 1. And you see that the midpoint between -3 and -1 is 1, right? No, it's not. It's not 1. It's -2. So it should be addition. Addition, not subtraction. x1 plus x0. See the real line. You have, for example, a, b. Okay? Ah, yes, yes, I understand the problem. We want this, the midpoint here, right? Assume 0 is here. The same idea for negative numbers, but let me show you for positive numbers. So here the midpoint, okay? How to find the distance, half distance between these two? It's b minus a over 2. This is what I found. So what we want is a plus b minus a over 2. This is the midpoint. But when you add, you get b plus a over 2. So we need to add the two numbers, and then you divide by 2. So let's do it again. So the midpoint between x0 and x1 is what? You add them, -3 minus 1 over 2, you get -2. Now, how to get the others? You add delta x, right? So call this x half, okay? For midpoint, okay? X half -2. Then the next one, call it x3 over 2. You add 2, you get 0, okay? The next one, call it x5 over 2. You get 2. Then x7 over 2, you get 4. Are you good with this? Do you understand how to find the midpoints? Do you hear me?
Yes, we can hear.
Is it good?
Yes.
Yeah.
Okay. Then you calculate the image at each point. You find f of -2, f of 0, f of 2, and you multiply them by delta x, and you get the area using midpoint, okay? Now part D, use the theorem above to find the exact value of the area. I think we will continue next time, right? We will solve this again, because we didn't solve the whole thing. I will take the names now. I think, yes, it's recorded. Yes, it's recorded. Because I felt that I forgot to record, but I'm recording. Now, let's take the names. You can leave if you want.
Professor,
Yes.
I sent you an email regarding my absences, but I didn't receive any reply.
When did you send the email? Do you hear me?
Yes,
Do you remember the email?
give me a second, I'm gonna tell you the date.
I will search it for it. You are Gaia, right?
Yeah, I told you about the first day of online classes and last week. There's also another one saying about the first day.
I didn't answer this, right?
Yeah, even the last one.
This for 14th April, right? I will include your name now for this one, and wait me a little bit and tell me the about the other one. Let's stop the recording.